In this video, we're going to go through identifying symmetry elements and operations within a molecule, as well as going through the point group flowchart to identify the proper point group for a molecule. We're going to use the molecules that we had on the quiz this past Friday. So the first molecule we'll look at is this trichloro methyl titanium complex. And so the first thing we can see is that it has a tetrahedral geometry, but it's not going to be in the tetrahedral point group because we don't have equivalent ligands at all four corners. We can see that we have 3 chlorides and 1 methyl group. And so these 3 chlorides are all going to be symmetrically equivalent by a C3 axis that goes through the titanium methyl bond. And so going through the flowchart to identify what the correct point group is, the first thing we can do is we can rule out that it's not going to be that it's not a linear molecule. So this is going to be a no. If we look at it and the question is, do we have multiple CN axes where N is equal to 3 or higher? Looking at the molecule, we have one C3 axis, but we don't have any more that are capable of providing equivalent positions. And so again, this is also no. The next question is, does it have a CN axis? And we've already identified that we have a C3 axis that goes through the titanium methyl bond right here. So this is a yes. However, the next question is, do we have a perpendicular CN axis? And the answer to that question is no, because we can't find one anywhere that will rotate any of these chlorides back into each other and leave this methyl alone as well. So we'll say that this is a no. And so based off of this right here, we already know that we're going to have a C-type point group. And so the next question is, do we have a perpendicular mirror plane? And so looking at this molecule, we don't have a perpendicular mirror plane because it's tetrahedral. So that is a no. Do we have a parallel mirror plane? So one that is parallel to the primary axis, and that is yes. And so if we look at this species right here, we can see that we have one mirror plane that incorporates this chloride, this titanium, and the methyl group. We have another mirror plane that incorporates this chloride, the titanium, and the methyl group. And then we have a third one that incorporates this chloride, the titanium, and the methyl group. So we have 3 parallel mirror planes, which gives us the answer yes. And so now that we have this answer right here, we can then tell that this is a C3V point group molecule. Now if we then go and we look at the next molecule that was part of that quiz, we can see right here it's a 1,2 tetrafluoro or 1,1,2,2 tetrafluoroethane molecule. And so we can see first from the beginning that we have a few symmetry elements that are present. We have a C2 axis that is right in the middle of these 2 bonds. It goes directly through here. We also have a mirror plane in the plane of the hydrogen, carbon, carbon, hydrogen molecules that then translates these fluorines into one another. And the same thing happens with the C2 rotation, where these 2 hydrogens, these 2 carbons, this fluorine, and then this fluorine and this fluorine translate into one another. So going through the point chart now, point group flow chart now, we can again say that this molecule is not linear. We don't have any CN axes that are greater than 3, so we can already rule that out. We do have a CN axis, as we said, so that's a yes. Do we have a perpendicular CN axis? And so looking at this species right here, we know that we have this CN axis that goes directly through the carbon-carbon bond, but if we had one that was perpendicular, this hydrogen would have to then translate into another hydrogen over here, which isn't the case. And so we know then that we don't have a perpendicular CN axis. Do we have a perpendicular mirror plane? Yes, we do. As we already established, we have a mirror plane in the plane of the hydrogen-carbon-carbon-hydrogen linkage, and that's perpendicular to the C2 axis right here. And so based off of that, then we end up with C2H. So if you give me a moment, I'm going to clear out the board a little bit to bring in the other two molecules. The next molecule we'll look at is this dimethylamine species right here. And so looking at this molecule, the first thing that we can see is that these two methyls have to be equivalent to one another, and there's nothing for this hydrogen to go into, and so we don't have a rotational axis available to ourselves. But we do have a mirror plane that puts these two methyl groups, makes them equivalent to one another. And so if we go through the flowchart again, we can see linear, no. Multiple CN axes, no. Do we have a CN axis? No, we do not. And so because of that, we can skip all of these right here. And then we go to the next question, which is, does it have a mirror plane? Yes. And so because it has a mirror plane, it has CS symmetry. So it's a CS in the CS point group. So the next molecule we're going to look at is this trans pentachloro trifluoro molybdenum complex. And so looking at this complex, we can see that we have these 5 chlorine ligands that are within the equatorial plane, and we have 2 fluorines in the axial positions. And so going through the point groups, we can see that the first question again is it linear? And no, it is not. The next question is, does it have multiple CN axes? So we can see that down this plane right here, or sorry, down this fluorine molybdenum fluorine bond, we can see that we have a C5 axis that rotates all of these chlorines into one another, but we don't have any other CN axes that are greater than 3. We don't have a 3-fold symmetric CN axis anywhere, or a 4-fold. The next question is, do we have a CN axis? And we do. We have the C5 axis that's right here, so this is a yes. Do we have a perpendicular CN axis? And we do. We have this C2 axis that goes through these 5 different molybdenum chlorine bonds right here. And so we have a perpendicular CN axis, and so that's a yes. So then the next question is, do we have a perpendicular mirror plane? And so if we look at it, we can see that we have one in the plane of the molybdenum and the chlorides, because as we can translate this fluorine into this fluorine right here, and everything else remains completely the same. And so because we do have a CN axis, so we have a 5-fold there, we have a perpendicular CN axis, so that gives it us a D, and we have a perpendicular mirror plane, and so the point group in this case is D5H.